Need some math practice to help you pass the GED or the TASC exam? Then you're in the right place. Hi, this is Parker from Test Prep Champions, here to help you pass the GED or the TASC, and you can get started by clicking subscribe down below. So practice tests are one of the most important things that you can ever do to help increase your score on a GED math or a TASC exam. And in this video, I've assembled some very helpful practice problems for you that are going to help you learn and master the fundamental skills that you need to pass a test like the GED or the TASC. And all of these questions, I've picked them out and screened them to make sure that they are going to be relevant on both the TASC and the GED math. So whichever test you're taking, you can be confident that these questions should be very similar to the types of things that you'll get. And try to get through all these questions because there's a lot of important questions and concepts to learn, not just at the beginning of the video, but also in the middle and at the end. So every question is important to understand. So try to be a champion and not a quitter, and try to push yourself to get through this entire video because I don't want you to miss anything, because just one or two concepts that you might pick up could be enough to make the difference for you between a passing score or a failing score.
Okay, question 1. When a spherical balloon is filled with air, it has a radius of 3 inches. Which of these gives the best estimate for the volume of air in the balloon in cubic inches? So go ahead, pause the video, try to figure this out, and then we'll go over it. Okay, so let's go over this. So there are a few words here that cue us into how to solve the question. So the first one is that word spherical. So that should right away make you think of a sphere. We also see this word volume. So if we look at what we're really being asked to find here, right, the question says which of these gives the best estimate for the volume of air in the balloon in cubic inches. So what are we being asked to do here? Well, we're being asked to calculate the volume of a sphere. So the volume of a sphere is given to us in this formula. So the volume of a sphere equals 4/3 pi r cubed. So what does this formula mean? Well, the formula, you can read it like this: 4/3 times pi times 3 raised to the 3rd power. So luckily we're told here that the radius is equal to 3 inches. So we can say that r equals 3. Now what about this pi symbol here? Well, for our purposes here, you can think of pi as being equal to 3.14. So that's something that you're going to want to memorize. All right, so pi is 3.14. Now, in real life, okay, pi is not really equal to 3.14. All right, the number goes on and on and on and on and on. So pi is equal to a number that starts with 3.14 and then it goes on and on and on and on. But for our purposes here, we don't care. For problem solving, we can just use 3.14 and we'll get a close estimate. So now what we're going to do is we're going to take this 3. So since we know that r is equal to 3, all right, we replace the r here with a 3. And since we know that pi is equal to 3.14, we're going to look at the formula here and we replace that pi symbol with 3.14. So let me show you how to set up this calculation here. So again, Vs is, the formula is for volume of a sphere. So we're just using the formula, which it's 4/3 times pi. And since we've already established that we can use 3.14 for pi, and that's going to give us a close estimate. And we also already know from the question that the radius is equal to 3. So we can just set this up like this. And so the easiest way to do this would be to just put it in your calculator. All right, so we can do 4 divided by 3, which is 1.333 repeating, times 3.14, okay, times 3 cubed. And I just put that in my calculator and it gave me 113.04. So remember, we're just looking for the best estimate here. So we're not looking for the exact volume, we're just looking for the best estimate. So I got 113.04 when I did my calculation here, which is very close to C, and C is the correct answer. So as long as you got something that was close to 113.1, 113.1, all right, if you got something close to C here, then you got the right answer. So congratulations, good job.
Question 2. Two triangles are similar, and the dimensions shown are in centimeters. What is the measure of x in centimeters?
go ahead, pause the video, and then we'll go over this. Okay, hopefully you had a chance to pause the video, try this out. So now let's go over it. So let's call this first triangle here triangle 1. In the second triangle, the bigger triangle, let's call that triangle 2 here. So we're told in the question that the two triangles are similar. Well, what does that mean? It means that the corresponding sides in the triangles are proportional. So if you're not sure what that means, then pay attention because we're going to go over that now. So I'm tracing the biggest side in triangle 1. And I'm also going to trace the biggest side down here in triangle 2. All right, so these are corresponding sides and they are proportional to each other. So therefore we can write this relationship. We can say 5/14. Okay. So what I want you to note here is that we're talking about the sides that are directly across from this little thing in the corner of the triangle that looks like a box. All right, so what is this thing in the corner here? Well, that represents a 90-degree angle. So these are both right triangles, and you can tell a right triangle because it's going to have that little box-looking thing in the corner here, which means it's a 90-degree angle. So the side of the triangle that's directly across from that little box type thing is what we call the hypotenuse. All right, so the biggest side of the triangle is the hypotenuse, and it's always the side across from the 90-degree angle here. All right, so these sides correspond. So we have this 5 and this 14, and we write 5/14. So now we also have to be aware that these two sides, right? So I'm talking about this side here that I just traced, and this side right here that I just traced. So these two sides also correspond, you see. So we have 2 and we have this x. So we can write this relationship. We have 2 and x, all right, because the corresponding sides are proportional. So now we have 5/14 is equal to 2/x. And if you figured out that you needed to write this equation here, then congratulations. If not, then make sure you understand why this makes sense. If you're still confused, you might want to rewind the video and watch it again, or just let me know down below in the comments and I'll see what I can do to help you out here. So at this point, what we want to do is we want to find x. So we want to isolate x, get it by itself on one side of the equation here, and the simple way to do this would be to cross multiply. Okay, so we're going to do x times 5. So let me rewrite this down here. So if we do x times 5, that gives us 5x. Okay, so we have 5x. Now we have 14 times 2. So I'm going to use a parenthesis to show that multiplication because we have 14 times 2. So what is 14 times 2? Well, 14 times 2 is 28. So we can rewrite that as 28. So we have 5x is equal to 28. Okay. So to get this x by itself, so again, what we have here is 5x is equal to 28, and we want to get this x by itself. So since we have 5 times x, we want to do the opposite operation here, okay, which is going to be division. So if we do 5x, divide that by 5, our 5's cancel out here. And the reason that they cancel out is because 5 divided by 5 is 1, which would leave us with 1 times x, which is just x, so there's no point in even writing the 1. So the 5's are canceled out. But whatever you do to one side of an equation, you also have to do it to the other side of the equation as well. So we have 28 divided by 5 now. 28 divided by 5, and that's equal to 5.6. So we can rewrite this now as x is equal to 5.6 centimeters. So cm for centimeters. So that is our answer.
Question 3. Sharon made a scale drawing of a triangular park. Her scale is 1 unit equals 1 meter. And the question says, what is the area of the triangular park
in square meters. So go ahead, try this one out, and if you can't get it, don't worry, we'll go over it. So pause the video now. Okay, so hopefully you had a chance to try this question out, and let's go over it. So it's asking us to find the area of the triangular part. So in other words, we want to find the area of the triangle. So the first step is to understand the formula for the area of a triangle. So the area of the triangle is equal to the base of the triangle times the height divided by 2. So it's the area of the triangle is equal to the base of the triangle times the height of the triangle divided by 2. So you might be asking yourself right now, how do I find the base and how do I find the height? Well, let's take a look at that. And so you could do it using these numbers here, but so we have these dimensions here, but there's an even easier way to figure it out. So since we've got the picture, we're just going to count, all right? So this part of the triangle, this line right here, all right, going straight across here, which I'm tracing in red just to show you, this is the base of the triangle. All right, and so we can just count each segment here. So we can count 1, 2, 3, 4, 5, 6 segments in the base of the triangle. So therefore we know that the base of the triangle is going to be equal to 6, right? So the base is going to be 6. So what about the height? Well, to find the height of the triangle, we want to look at the highest point of the triangle, which is right here, right at the top of that triangle. Then we want to count these segments, right? So we can count 1. Let me show these going across. So we got 1, 2, 3. All right, so we can see that the height is 3. All right, and sorry about that. There's a car alarm going off outside. I do live in Philadelphia, and as in all cities, that happens quite often. So I'm going to try to edit that out. So if you didn't hear it, then just pretend I didn't say that. But anyway, so we've got the base times the height. So we're going to do, let me rewrite this here. So we've got 6 times 3 divided by 2. And there's 2 ways to do this. So you could just do 6 times 3, which that equals 18, and then divided by 2, and that equals 9, and that's going to give you the answer. Or you could have done it a different way. So you also could have looked at this and you could have seen 6 times 3, and you could have done a simplification here. So you could have done 6 divided by 2, right? And if you do 6 divided by 2, you know that that equals 3, which would leave you with 3 times this 3 here. And we already know that that's going to equal 9. So there's 2 ways to look at the same calculation, but either way the answer is 9. So if you got that right, great work. Okay, question 4. What is the solution to the equation 2 times x minus 10 plus 4 equals negative x plus 2? Pause the video, now's your time to shine, give this a try, and then we'll go over it. Okay, so hopefully you just had a chance to pause the video and try this out. So let's go over how to do it here. And there are multiple approaches, but I'm going to show you the best approach to do it here, in my humble opinion. And that is to just solve the equation, right? We're going to distribute this 2 here. Okay, but first, before we even talk about that though, what does it really mean to solve the equation? So it says, what's the solution to this equation here? So what we want to do is we want to find out what the variable is equal to. So we want to get this variable by itself on one side of the equation. So you might be wondering, what's a variable? Well, a variable is just another way of saying an unknown. So this x is equal to a number. We don't know what it is right now. So the value of x is unknown, and that's why we're trying to solve this equation here. So we're trying to get x by itself on one side of the equal sign, and that's going to tell us what x is equal to. All right, so the best approach here would be to first distribute this 2. So what do I mean when I say distribute this 2 here? Well, you have to do 2 times x, so we can rewrite that down here. So we're going to do 2 times x, and then you have to do 2 times 10, but we have to take into consideration this minus here. Okay, so it's 2 times 10, which is 20, but we bring that minus along. So we now have 2x minus 20. Then we've got plus 4 here, because we're just going to bring that 4 down for a ride because we didn't touch it, we didn't change anything, and that's equal to 6x plus 2. So The only thing that I did in that step was to distribute this 2. So again, we did 2 times x, which gave us 2x. Then we did 2 times 10, which is 20, and we bring that minus down, right? So we've got to take this minus along for the ride here. So we have 2x minus 20 plus 4 equals negative 6x plus 2. Okay. So again, remember, the strategy here is that we're trying to solve for x. So in other words, we want to get x by itself on one side of our equation here. And there's a couple different ways you could approach this here. All right, and so here's how I would do it. So we want to first, let's try to isolate our variable here. So we've got minus 6x, right, or negative 6x, however you want to think about it here. So we can add 6x to both sides of our equation here. Okay, so if I add 6x over here, so we have minus 6x plus 6x, that's going to cancel out here. Now, whatever you do to one side, you also do to the other. So we're going to end up adding 6x over here. So 2x plus 6x gives us 8x. So now let me rewrite this. So we'd have 8x minus 20 plus 4 equals our 2. Right, so our 2 is just left by itself. And like I said, there's a couple different ways to think about this, but this is just one way to do it here. So we've got 8 times x, right? We've got our 8x over here, and so now we have 8x minus 20 plus 4. So I want to keep trying to get this x by itself on the left-hand side of the equation. So let's get rid of these numbers here. So we've got minus 20, right? So the opposite of minus is plus. So we've got to add 20 here. So minus 20 plus 20, these cancel out. All right, so at the same time, we have whatever we do to one side, we have to do to the other. So let's just write this 20 up here. So we added 20 to the left-hand side of our equation, and therefore we also have to add 20 to the right-hand side of our equation. Now, we also have this 8x plus 4, so we can do minus 4, right, to get rid of this. And again, whatever you do to one side, you also do to the other. So we have to subtract 4 from this side as well here. So that leaves us now with 8x. And that's equal to 2 plus 20. So 2 plus 20 is 22. All right, and what about 22 minus 4? Well, 22 minus 4 is 18. So we now have 8x equals 18. Okay, so how did I get that 18? Well, what I did was I did 2 plus 20, which gives us 22. And again, we still have that 4 here. So 22 minus 4 is 18. So that's where that 18 came from. Okay. So let me clear that out of the road here. So we now have 8x equals 18. And again, the goal here is to get the x by itself on the one side of the equation. So since we have 8 times x, we want to do the opposite of multiplication, which is division. So we want to divide by 8. All right, so 8 divided by 8 is equal to 1. So these 8's are gone, and again, whatever we do to one side, we also do it to the other. So we also divide by 8 over here. So we have x equals 18 over 8. So I don't see that as one of the answer choices though. So did I do something wrong? Well, no, I didn't do anything wrong. We just haven't simplified our fraction yet. Okay, so the easiest way to do this is, since we've got 2 even numbers right here, we can just divide both the top number and the bottom number by 2. So let's do that. So what's 18 divided by 2? That's going to give us 9. And if we do 8 divided by 2, that gives us 4. So now our fraction is in simplest form. So x equals 9 over 4. And that is answer choice C. So C is the correct answer. Question number 5. Water pours into a tank over a 10-minute period. The graphed function f of x models the flow rate in gallons per minute. And then we see the model here, right? We see the graphed function, and then the question says, over which of these intervals does the flow rate increase by the greatest amount? A, x equals 0 to x equals 1. B, x equals 2 to x equals 3. C, x equals 4 to x equals 5, or D, x equals 8 to x equals 9. So pause the video, you know the drill, try this out, and then we'll go over it. Okay, so let's go over this question here. So the best way to do this is to look at each of the answer choices, and then we're going to use process of elimination. So we have to remember that the intervals, right, are given to us on our x-axis, right? So this horizontal axis here that I'm going to trace briefly, all right, this is our x-axis, and that shows us the time in minutes. All right, and so now the other axis, right, this vertical axis on our graph, all right, is called f of x, or function of x. Okay, and that gives us the flow rate. So what we want to do is check each interval here, and we're going to try to find the flow rate increase, and we want to look for the interval with the greatest flow rate increase. So let's look at A. X equals 0 to x equals 1. So right here on our graph would be 0, so I'm going to write 0 in here. So from x equals 0 to x equals 1, during this interval here, we want to look at what's going on with our flow rate. All right, so the flow rate starts at 40, and it increases right here. Okay, so it doesn't quite hit 50. All right, but it gets to be somewhere close to 50. So we could say it looks like it stops about here. So we could say that it goes from 40 to 47, just about. All right, so if we subtract that, 47 minus 40, we can say that in this interval here, there's about, right, there's a difference of about 7. Okay, so we can see that the increase in flow rate here is about 7, okay, during the interval from 0 to 1. Now again, all I did was I checked that interval on the x-axis. I checked 0 to 1, so I looked in this interval and I want to look here and I wanted to look at what was going on with the flow rate here. So I looked over here at the y-axis. I saw that at 0, okay, the flow rate was at 40. Then at 1, I saw that the flow rate was close to 50 but not quite 50, so I estimated that it was about 47. So then I wanted to take the difference. Okay, so the difference of at time 1 versus after 1 minute versus at 0 would be 47 minus 40, and that gave me 7. Okay, so hopefully that makes sense. So now let's check answer B. So x equals 2 to x equals 3. So let's find that interval here. So from x equals 2 to x equals 3, okay, we're going to look at what's going on with the flow rate between 2 and 3 minutes. So right here on the graph, what we notice here is that the graph is flat right here. Okay, so flat right off the bat, that should tell us that there's no change. So there's no change, there's no increase going on here. Okay, now we can check this mathematically, right? So look at the flow rate at 2 minutes. So after 2 minutes, the flow rate is at 50. And then after 3 minutes, the flow rate's also at 50. So if you want to do the math here, 50 minus 50 is 0. So the change in the flow rate here is 0. So there's no increase or decrease. So B is not going to be the answer, right? There's no change in the flow rate. So now let's look at x equals 4 to x equals 5. So from the interval, right, so here's where x equals 4, here's where x equals 5. So we want to look at the flow rate in that interval. So I'm going to trace that. And so right off the bat, what I want you to see here, you don't even need to do any math because you should be able to tell that, look, the flow rate's decreasing here, right? So the line's going down, all right, which tells us that the flow rate is decreasing over this interval. Okay, so if we want to do a little bit of math here, we could say that at 4 minutes, maybe the flow rate is maybe, we could say 47, something like that. Then at 5 minutes, it looks like it's maybe 38, something like that. So if we do 38 minus 47, what happens? Well, we're going to get a negative number, okay? And that should tell you that there's a decrease here. But you don't even really need to do any math. You can just visually see that, hey, the line is going down during this interval. So between 4 and 5 minutes, we see that the flow rate's decreasing. So this isn't going to be the answer. Okay, so lastly, we check D. And D is the interval of between 8 minutes and 9 minutes, right? So we want to look at what's going on with the flow rate between 8 and 9 minutes. And so again, the graph is flat here, so there's no change going on here. So the answer is A. Okay, question 6. The table gives selected values for the linear function f of x. And so we see the table here. Which of these functions has the same slope as f of x? A. G of x equals x plus 7. B. H of x equals 2x plus 2. C. Q of x equals 4/5 x plus 8. Or D. P of x equals 7/5 x plus 5. So pause the video now, try to figure this out, and then we'll go over it. Okay, so let's go over how to do this. And so this question might appear a little bit complex at first, but it's really not that hard if we break it down. So again, we want to pay close attention to what the question is asking. And in this case, it's asking us which of the following functions has the same slope as f of x. So what does this really mean? So we have to understand a little bit about functions and function notation here. So this f of x, what it really means here, all right, is that we have an input and we have an output. So a function is a relation between an input and an output. And so in the function notation, okay, this is what is the name of the function. So in this case, for f of x, the name of the function is f. Okay, so just like in this function here, g function, all right, we have g of x, the name of the function would be g, and in b we have h of x, so the name of the function would be h. Okay, so hopefully that's pretty clear. And x is the input, all right? So whatever's going into parentheses here is the input of the function, all right? And so you're going to put something into the function, and then you're going to get an output here. And so that's what's going on here in the table, okay? So this word says input. It's kind of hard to squeeze it in here, but all of the x values here in this table are inputs, and the f of x values show us our outputs. So if you put 5 into the function, you get 12 out. If you put 10 into the function, you get 19 out. And if you put 15 in, you get 26 out. Okay, so one way to think about it would be to imagine like a vending machine where if you put $1 in, you might get some chips. You put $2 in, you might get a soda. You put $3 in, you might get a candy bar or something like that. So it's like you're putting something in and you get an output. So you get an input and an output. So that's the basic idea of a function. All right, and so when we think of f of x here, okay, we can also think of that as y. So a function of x, we can just say that that's equal to y. So when we calculate the slope, we have to know this special formula here. And so this m represents slope. So whenever you see this formula for slope, you'll probably see it written with an m, and just know that m represents slope. So the formula to calculate slope is y2 minus y1 divided by x2 minus x1. Okay, and so now these are all x values and these are all y values. So at random, we can pick any one of these values and we can call it x1. All right, and we can pick it at random. So we could make 5x1, or we could make 10x1, or we could make 15x1. It does not really matter. We could make 20x1. So I'm just going to randomly pick 10. So let's say that 10 is our x1. All right, so let's say that 10 is our x1. All right, so in the function here, 10 is the input, 19 is the output. So then I would have to make 19 my y1. Okay, so as long as you keep you've got to keep the input and output together here, right? So if I had picked, let's say instead of picking 10, let's say I'd made 5 my x1, then the y1 has to be 12. All right, so see how we have to match the input with the output here. Okay, but you can pick the x1 at random here. So let's just pick 10, make this x1. So then the number that's paired with 10 is 19, so that's my y1. Hopefully that makes sense here. So now I'm going to pick an x2, and again, this is just done randomly, so I'm going to make my 20, I'm going to pick that as x2. Okay, now like I said, I just picked that at random. I could have just as easily made 5x2, or I could have made 15x2. Okay, so you just pick a random x value here. The only thing is you've got to make sure that you make the output, all right, you have to take the output that's paired with that input and make that y2. So in other words, if I make that my x2, 33 has to be my y2, all right? So what I couldn't do is this. I couldn't say, well, 20, I'm going to make that my x2, and then I'm going to make this 12 here, I'm going to make that my y2. Okay, that won't work. We want to pick the output here, right? So that way we've got our x2 and we've got our y2, all right? And so now we're just going to substitute these values into the equation. All right, so for where we see y2 in the equation, we're going to substitute 33 in. And where we see y1, we're going to substitute 19 in. And where we see x2, we're going to put 20 in. And then where we see x1, we're going to put 10 in. Okay, so let's do this here. So let me clear these arrows out because it's going to make it a little bit more cramped here. But since we made 33 our y2, we're going to replace the y2 with 33. And then for y1 here, we're going to use 19. And then for x2, so we're going to take our 20 here. And we subtract 10. All right, and let's do the math here. So what's the answer here? So what's 33 minus 19? Well, that gives us 14. And then 20 minus 10 gives us 10. So now we've got a fraction. So let's put this in simplest form. So we've got two even numbers, so we can divide both the top number and the bottom number by 2. So 14 divided by 2 is 7. 10 divided by 2 gives us 5. Okay. So that's one way to calculate the slope. But let's say that we had done it a different way. So I just want to show you that you can pick anything at random here. You just have to keep the ones and the twos together here. So if we had done, let's say we had made 5 our x1, therefore we had made 12 our x1, or then we'd have to make 12 our y1. And let's say that we picked 15 as x2, and that we picked 26 as our y2. So just watch what would happen here. I'm just going to plug this into the formula quickly here. All right. So let's say that we had made our y2 26 and our y1 was 12, and then our x2 was 15. And I'm doing this fast intentionally here because I just want to prove a point here. And our x1 would be 5. And so let's watch what happens here. So 26 minus 12, that equals 14. And 15 minus 5 gives us 10. All right, and so again, we've got two even numbers here. We can divide 14 by 2, 10 by 2, since they're both even numbers, and we get 7 over 5. So see, when I said that we could assign the x1 and x2 at random, all right, because it's going to give us the same answer, so we do that at random. The only difference is that, the only thing that you have to keep in mind is that when you've got a set of inputs and you've got your outputs here, you have to pair the x1, all right, the number that's paired with it has to be your y1. And so if you pair, so like I said, if you make this x1, this would have to be your y1, all right? So you couldn't make 5 your x1 and then make like 19 your y1. That would not work. All right, so anyway, but the slope we just found is 7 over 5. So we're not quite done yet. We now have to find which function has the same slope as function of x. So really that's fairly simple. So if you understand the standard form of a linear equation, all right, the standard form of the linear equation looks like this. It's y equals mx plus b. All right, and in this equation here, your b is your y-intercept. So b is the y-intercept, and the y-intercept is on a graph. So for example, let me draw a graph right here. All right, so say this is a graph, and say I have a line that goes through the graph. So the horizontal axis on a graph is our x-axis, and the vertical axis that goes up and down is the y-axis. And so right here at this point here, the point where the graph crosses the y-axis is what we call the y-intercept. All right, and so the slope here, this m right here is the slope. Okay. And if you're sitting there wondering, do I really need to know this for my test? Is this just side information? Absolutely not. In fact, this is very, very crucial to understand for your test here. And I'm not even going to go as in-depth as I could right now on this, but know that you absolutely do need to understand this. So if I'm showing you this standard form of linear equation and you're confused about this, or you've never seen it before, or all this stuff about functions, if you're not really sure what I'm talking about, then I highly, 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 highly recommend that you get back into your textbooks or watch other videos, because you do need to know that stuff for your test here. But basically, in the standard form of a linear equation, we see that this m is our slope. All right, and so all of these equations are in the standard form. So for example, if we look at b, we see h of x equals 2x plus 2. Well, this 2 is the slope, and this 2 is our y-intercept. All right, so for c, the 4/5 x, that's the 4/5 is the slope, and 8 is the y-intercept. So in D, we see that 7/5 is the slope, and so we can then say that this function right here, all right, the function p, right, so p of x in function p, all right, which is answer choice D, we see that it has the same slope as function of x. So D is the correct answer. Question 7. And if you're still here right now, then you're doing a phenomenal job. many people quit. They gave up, or they just didn't want to put the work in or make the sacrifice to really improve their lives through learning to understand this math. So if you're still here right now, you're doing a phenomenal job, and I just wanted to acknowledge that and congratulate you for taking such a big step. So with that said, let's get to number 7 here. It says Tom has 2 cubes with one of each number, 1 through 6 on each of the 6 faces. He rolls the cubes at the same time and finds the sum of the numbers that show on the top. The sample space of all the possible outcomes is 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Which subset describes the possible outcomes for a roll in which one of the cubes shows a number less than or equal to 3 and the other cube shows the number 4? So the way this question is worded makes it seem kind of tricky here. So if you can't get this one, don't feel bad, but give it a shot right now. Pause the video, see what you can do, and we'll go over it. Okay, let's go over how to do this question. So I'm going to draw pictures here so we can visualize what's going on. Anytime you get a word problem or a complex problem, breaking it down in simple pictures is always a really helpful way to think about it. So basically, we've got 2 cubes here, and I'm not really going to draw cubes. I'm just going to draw the square faces of cubes. So these are the 2 cubes here. So think of this like they're playing dice, like they're shooting dice here, and there are 6 faces to each cube, and they've each got a number 1 through 6. So basically, he rolls 2 cubes at the same time, and then he adds them up. So let's say you roll 1 die, and then you roll the other die, and then whatever you get on the first die, like if you get a 2, and on the second die you get a 3, then he's just adding those numbers up, right? So that's basically what's going on here. So the sample space of all possible outcomes is all of these numbers here. So what I want you to notice here is that there is no number 1. So why is there no number 1 in this set of numbers right here? Well, we can't get a number 1, right? Because the lowest possible number we can get is 2, right? Because let's say you roll this die and you get 1, and then let's say you roll this die and it lands on 1. So if you add these up, obviously 1 plus 1 gives us 2, right? So there's no way to get just 1, because both die are numbered 1 through 6. So that's why the lowest number is 2 here. So it's just showing all the possible outcomes that you could get. So then it asks us, it says, which subset describes the possible outcomes for a roll in which one of the cubes shows a number less than or equal to 3, and the other cube shows the number 4? So let me redraw these cubes down here. So let's say that this is the first cube here. So it says, let's say that one of the cubes shows a number less than or equal to 3. So what are all the possible cases you could get for this first cube? So it's going to show a number less than or equal to 3. So it could be a 3, right? Because it says less than or equal to 3. So this cube could land on a number equal to 3. Now it could also be 2, or it could be 1, right? Because it's just showing you that it could be a number less than or equal to 3. And we know that there's no 0, right? Because it tells us right here that they're numbered 1 through 6. So it could either land on a 1, you could either get a 2, or you get a 3, right? So I guess when you're rolling die, you don't really say the die is going to land on 3, but maybe you do, I don't know. But you get the point here. And so this one has to be 4, because it says, and the other cube shows the number 4. So this cube's going to be 4 here. All right, so basically, we're just looking at the different combinations of numbers that we could get here. So let's say that the first die you roll a 1, and the second die you get a 4. So what does that add up to? So 1 plus 4, that equals 5. So one option would be 5. Now, instead of rolling a 1, let's say you roll the first cube and you get a 2. And we know that the second cube's always going to show 4. So then we would be doing 2 plus 4, right? Because if this one lands on a 4, or I'm sorry, if this first one lands on a 2, or if you roll it and you get a 2, I should say, and you roll the second cube and you get a 4, if you add them up, that's going to be 6. So you can probably already see the answer here, but let's keep going with this so you really understand this. So let's say that you roll the first cube and you get a 3, and the second cube you roll that, you get a 4. So what would the sum be? 3 plus 4, that's going to be 7. So the answer is C, 5, 6, or 7. And that just whited out that answer, but the answer is C here. There we go. Question 8. The price of a certain sofa, S, is $900 more than the price of a chair, C. The total price of the sofa and chair is $1,200. Which system of equations can be used to find the price of each piece of furniture? So go ahead and pause the video now and try to figure this out. All right, let's go over this. So first of all, whenever you see terms on your test like system of equations, if you see terms like this and you don't know what they mean, don't freak out, don't panic, because you can usually still reason your way through the question even if you're not familiar with some of the math terminology. But basically, system of equations, you've got multiple equations and they share variables. That's all it means basically. So, but for this question, you don't need to know what this means. The strategy to get this question right is just to translate these two sentences into mathematical equations. So the first sentence here, it says, the price of a certain sofa, S, is $900 more than the price of a chair, C. So how can we turn this into a mathematical equation? Well, it says the price of a certain sofa, S. So we're going to start with S. So it says S is $900. So this word is right here, that's going to translate into an equal sign. So S is $900 more than, and more than, that's a key term, right? So that's a keyword or a keyword phrase that translates into a plus sign. So S is, so is that equal sign, $900 more than the price of a chair, which to represent the price of a chair, they're just using the letter C. So here's the equation we get. So S equals 900 plus C. S is 900 more than the price of a chair, C. So that's our first equation, right? And the total price of the sofa and chair is $1,200. So now it says the total price for the sofa and chair is $1,200. So let's let S now represent, again, the price of the sofa, and it says total price, so total, all right, that's going to tell us to add the total price of the sofa and chair. So we want to do S plus C for the price of the sofa plus the price of the chair. And again, total, that word tells us that we need to add here. All right, so that's equal to 1,200. So basically, we just want to look for the answer that has both of these equations in it. So in this case here, let's see. So we've got S plus C equals 1,200. S equals C plus 900. So A is going to be the answer here. And so you might be wondering, well, we wrote S equals 900 plus C. Well, it's really the same thing, right? And that's a basic thing you need to understand. That's a basic principle of math. Whether we write it as S equals 900 plus C or S equals C plus 900, the order of the 900 and the C doesn't matter because it's still the same thing. So A is the correct answer. Okay, question 9. Consider this polynomial expression. So we see two polynomials. So let's call everything in the parentheses, between these parentheses here, that can be like polynomial 1. And this is the second polynomial. So this is polynomial 2, let's say. So we're adding these up. And it says, what is the sum of these polynomials? So go ahead, try to add these polynomials up, and then we'll go over it. Okay. So let's go over this. And so basically, when you're adding polynomials, you have to deal with what are called like terms. All right, so it's very important that you work with the like terms here. All right, so I'm gonna put this in quotes here, but remember that we're dealing with like terms here. Okay, so what I mean is that if we've got a term that has an x squared, we're not gonna try to add that x squared with a 9, okay, or in this case, minus 9. So we have to look at the x squared terms, and those are what we're going to add. And likewise, the terms with the x's and the terms with just the numbers. All right, so let's go through this here. So we're going to look at our x squared terms first. And we've got to look at the number in front, right? So in this case, we see x squared. There is no number in front, so we just assume that it's 1. And that number in front, by the way, the technical term for it is coefficient. So in this case here, right, so we want to look at the second polynomial and add up and add this. Okay, so we're going to add this to the first polynomial, but we've got a 2. So the coefficient in the x squared term of the second polynomial is 2. All right, so now if we look at polynomial 1, the next term is this x term. So we've got minus x. And so then over here in our second polynomial, we have plus x or positive x, right? So hopefully you can tell right off the bat that we've got like minus 1 and plus 1. All right, so we're doing minus 1 plus 1 because remember the x's, you just think of it as having an imaginary 1 out in front of it. So hopefully you see that that's going to be 0 already. And then we also want to add up the numbers here. So to rewrite the polynomial over here, we've got +1. Then down here we've got -9. Okay, so now we can add these up. So we're not going to touch the x squared itself. We're just adding the numbers in front of it. So remember I said you can think like there's an imaginary 1 here. So you do 1 plus 2, which gives us 3. And you just bring that x squared down. You don't change it. So we've got 3x squared. Now we've got -1 plus 1. And so that's, hopefully you know that that's going to be 0. But let me just show you for the visual learners why that makes sense. So, and even if you're not a visual learner, you'll want to understand this concept here. So on a number line, we've got -1, we've got 0, and we've got 1. So think of these as like stepping stones maybe. So there's a stick figure. So let's say you're at -1 right here. And so we go +1. So if you add 1, you're going to go in this direction. So if you're at -1 and we do +1, right? So if you add 1, you take 1 step and you're on the 0 here. So -1 plus 1, all right, that's going to be 0. So we've got 3x squared plus 0, and we don't even need to write that 0 there. So now we've got +1 and we've got -9. So what's 1 plus -9? All right, so 1 plus -9, that's going to give us -8. And so again, if we think about this visually, so let's look at like we're on the number line. So let's say here's -9, here is -8. All right, so let's say that these are like stepping stones and you're on the -9. Okay, so you've got, and then you're going to add 1. All right, so that means that you're going to take 1 step in this direction here. All right, so if you add 1, you get a bigger number. So -8 is a bigger number than -9, and that's a little bit confusing for some people to understand. But the reason is because this direction on the number line, so going this way, all right, the numbers actually get bigger and bigger because they're getting towards 0, and after 0, if you pass the 0, right, and you keep going in that direction, you keep getting bigger, like 1, 2, 3, 4, 5, right? So that's why that is. So we're at -9, we add 1, it gets us to -8 here. So anyway, the point of that drawing is just to show you visually, for the visual learners out there, that it's going to be, the answer would be -8. You can also just use your calculator or just know off the top of your head, because you guys are great. You probably already are understanding basic math by now if you've got to this point in the video. But if not, we just want to understand that when you've got a positive number and you're adding a negative, okay, that's how you would do it. So you got 1 plus -9. You're basically just doing 1 minus 9, okay, which would be -8. So we got 3x squared minus 8. And the answer is going to be B. Okay, question 10. Consider this function. Function of x equals -2x plus 7. What is function of -3? So go ahead, pause the video, try to figure this out, and then as always, we'll go over it. Okay, so this one might appear, like a lot of these questions, it might appear a little bit harder than it is if you're not familiar with functions. So we've already been talking about functions a little bit, but basically what's going on here is that this x, that's the input. All right, so it says, what is function of -3? So basically what we're going to do here is everywhere in this question that you see an x, which is only in one place, you're going to replace that x with -3. So we can rewrite this here. So it says function of x, and so we're going to replace, again, we're replacing that x with -3 here. All right, and so we've got -2, and instead of an x, remember, we're going to replace that with -3. And we still have this plus 7 here, okay? So we're just going to do the math now. So what's -2 times -3? Well, that's going to be 6, because 2 times 3 is 6. A negative times a negative gives us a positive. So we've got function of -3, and that's equal to 6 plus 7. And 6 plus 7 is equal to 13. So the answer is just 13. Question 11. The surface area, SA, of a square prism is given by SA equals 2s squared plus 4sh. In the equation, s is the length of the side of the square base and h is the height. Which formula could be used to find h if you know the values of SA and s? So pause the video now and let's go over this. All right, let's go over this. Actually, what I meant to say is pause the video, try it out, and then we'll go over it. But hopefully you got the point by now. And basically what we're going to do here is, again, a lot of this information just doesn't matter in these questions here, right? So we don't care. S is the length of the side of a square base. H is the height. We don't really care here. All right. All we need to know is we're trying to find a formula that you could use to find H. So basically, we're just going to take this equation here, and we're going to solve the equation for H. So right here we see our H. And when I say solve the equation for H, what I really mean is we're going to use some mathematical manipulations, all right, or some algebra to get the H by itself on one side of the equation. So right now you see that this SA is by itself. It's all alone. There's nothing else there on the left-hand side of the equation but SA. So this equation is solved for SA. But that's not what we need. We need to solve the equation for this H. So we're just going to do some basic algebra to get this H by itself. So the way that we do that, all right, is we see first we've got 2s squared plus 4sh. So we always want to do the addition and subtraction first when we're solving equations. Now, a lot of people, they think of PEMDAS. They think of the order of operations rules. And the order of operations rules, right, some people get a little bit confused here because basically PEMDAS, it means you do stuff in the parentheses first, then you do the exponents and square roots, then you do multiplication, then you do your division, then you do your addition and your subtraction, right? So that's what PEMDAS means. And this is really important skill to know here. You got to understand PEMDAS and the order of operations rules. So students a lot of times get confused because you do want to do the addition and subtraction last. So when I say you want to handle the addition and subtraction first here, a lot of people get confused and they say, why is that? Now, you'll just want to take my word for it here that when you're solving equations, you do want to handle the addition and subtraction first. All right, so I could prove to you mathematically why that makes more sense to do it that way, but it's going to take a long time. So just take my word for it. You got to trust me here. I'm telling you, you really have to trust me here. You want to do the addition and subtraction first when you're solving an equation. In all other cases, right, you do want to stick to your multiplication and division first, and always do the parentheses first. But in this case, trust me, you got to handle that addition and subtraction first. So we've got 2s squared plus 4sh. So this 2s squared, we can subtract that on both sides of the equation. Right, so we can subtract the 2s squared from this side of the equation, and that's going to clear it off of that side, but whatever you do to one side, you're also going to have to do to the other. So if we subtract 2s squared from this side of the equation, we're also going to have to subtract it on the left-hand side as well. So we're going to end up with SA minus 2s squared plus 4sh. Or I'm sorry. Now we've got equals 4sh. So I'm just keeping you guys on your toes here. So now we see that we've got 4 times s times h. So the opposite or the inverse operation of multiplication is division. So since we have 4 times s times h, we want to get this 4 and this s, we want to get rid of it. So we want to do the opposite of multiplication, which is division. So we do 4 times s divided by 4 times s. That's going to clear this out. But whatever we do to one side, we also have to do it to the other side. All right. So we end up with 4s over here. So this whole thing here is going to get canceled out here. So pretend this whole thing is gone, right? And we're just going to be left with SA minus 2s squared divided by 4s equals h. So the correct answer for 11 is B. There's still some of you out there and you might be a little bit confused about why did I do that addition and subtraction first? So let me show you. I'm going to go rapid speed mode here because I think that this is important to understand this here. So let's say that we tried to do the division first, right? So we have plus 4sh. So in order to divide 4sh here, right? So if we want to divide this 4 and this sh, we've got to divide every term here by 4s, right? So we can't just do, right, because this is 2s squared plus 4sh. So if we want to try to divide this 4s, we've got to divide it from each term here. So hopefully you can already see how this is starting to get a little bit, it's already starting to get a little bit messy here, right? So the 4 and the s are going to cancel out. So we're left with 2s squared over 4s plus h. But like I said, here's where things start to get a little bit weird because remember, we've got this plus here. So this whole term we're going to have to subtract from the left-hand side of the equation. So here's what we're going to get. We're left with SA over 4s minus 2s squared over 4s, which that equals h. All right, so we see here that we've got a common denominator. So we've got SA over 4s minus 2s squared. So the denominator is the bottom term in the fraction. So the bottom number, or everything in the bottom of a fraction, basically is what we call the denominator. So when you've got a common denominator, you handle that by just subtracting the two numbers, or the two terms up top, right? So we can really rewrite this whole thing as SA minus 2s squared all over 4s, and of course this still equals h. So either way you slice it here, you're still going to get the same answer. But like I said, see how this way to do it, where you do the multiplication or you do the division, multiplication and division first, see how it gets a little bit trickier here. Now you guys are smart, you guys are great. So some of you out there watching this video right now, you probably followed what I did just fine. All right, but just remember, if you're having a little bit trouble understanding this second way that I showed you here, just remember, just when you're solving an equation, handle your addition and subtraction first. It's just going to make it a lot easier, because then you don't have to deal with common denominators. Okay, question 12. While visiting Brazil for 6 days, Shan has a budget to spend an average of $16 per day on food. The conversion rate is $1 equals 3.16 Brazilian real. The first day of vacation, he spends 63.20 on food. What is the average number of US dollars per day Shan can spend on food for the remaining 5 days of his vacation? So go ahead and try this one out, then pause the video and we'll go over it. Okay, so basically, there's a lot going on here, so I really want you to focus on this question, because there's a lot of lessons to learn here, and I want you to see if you got this one right, and if you understand it, because this is pretty tricky stuff. So basically, let's break this down. So Shan, he is visiting Brazil for 6 days, and he has a budget to spend an average of 16 US dollars per day on food. So right off the bat, this is a little bit tricky here, right? Because he wants to spend an average of 16 US dollars per day on food. So right off the bat, we can calculate we can just say like his total budget, right? Or his overall budget. So I'm just going to put TB here, or I'll write it out. Let's say total budget, all right? So his total budget, we can find that easily here, because he wants to spend $16 per day on average. So if he does that, let's just assume $16 a day on average, and we're talking about 6 days here. What would be that total budget, or that big budget? So 16 times 6 would be 96. So if you spend an average of $16 per day, all right, then the total amount that he wants to spend for that whole trip would be $96. So then we've also got this conversion rate. And what's the point of this conversion rate right here? $1 equals 3.16 Brazilian real. Well, this is going to tell us the amount that he spends on that first day. So what does that matter? Well, we know that he wants to spend an average of 16 US dollars per day. So this 63.2, that's in Brazilian real. So we want to convert that to US dollars, because then that's going to tell us how much he spent on the first day in US dollars. Now, if that number equals exactly 16, then there's really not much point in the question here, because then we would know that that just tells us that on average he's going to spend $16 for the rest of the week, so he'd be on perfect pace to do that. However, math questions usually don't work out that nicely here, so this number is probably not going to be equal to 16. So we can do our conversion right now. Let's get that out of the way here, and let's figure out how much he spent the first day in US dollars. So we've got 63, and I'm going to put the 63.2. I'm going to put the R here for Brazilian real. Now, this conversion rate is $1 equals 3.16 Brazilian real. So we're going to set this up so that we put the Brazilian real amount down here in our denominator, because we want the units to cancel out. So what do I mean by units? Well, basically, the unit is the R here. So if I've got 63.2 R times, and then up here I put the US dollar first. So for $1 divided by 3.16 R, all right, so you can see if we do the division here, the R's are going to cancel out, because R divided by R, anything divided by itself just equals 1. All right, so those are effectively going to cancel out here. And so we've got, so if we do the math, we do 63.2 divided by 3.16. Okay, so that's going to give us 20. So that gives us 20 US dollars. So what does that tell us? So on the first day, he's already over his budget because he spent 20 US dollars. I'm just going to now put a dollar sign in 20. So we know that the total budget, right? So based off of that initial sentence here, it tells us that if you spend $16 a day on average for 6 days, that would be $96. But he already spent 20 on the first day. So let's see, based off of that total budget amount, let's see what he would then have left for the rest of the week. So to do that, we would do 96 minus 20. Okay. And so 6 minus 0, we just bring the 6 down. And 9 minus 2 is 7. So he has $76 total budget now left after that first day. But we want to know what's the average number of US dollars he can spend per day on food for the remaining 5 days. So we got to take that $76 value. We then have to divide that by 5. And we do the math here. And I'm just going to throw that in the calculator because that's the easiest way to do it. 76 divided by 5. That's going to give us 15.2. So the answer is 15.2, $15.02. Okay, question 13. Select the 3 expressions that represent a rational number. So pause the video, go ahead, and then we'll go over this. Go ahead, try it out, and we'll go over it. Okay, great. So this is a really great question here because there's a lot going on here. So first of all, what is a rational number? So I'm going to abbreviate that as RN here. And I don't mean registered nurse, obviously. I'm talking about RN, meaning a rational number. So a rational number, it's basically a number that can be written as a fraction. So that's very important to note first off, because if you don't even know what a rational number is, then you're not going to be able to get the question right. Now, don't worry if you didn't know what a rational number was up until right now, because you got to learn somehow. So it's a good thing that you're learning what a rational number is if you didn't know it. So don't be hard on yourself if you didn't know that. Now you know. And so basically, we also have to keep in mind that there are certain square root values that are going to give us rational numbers, and certain square root values will not give us rational numbers. So, for example, there are common square roots that it's a good idea to memorize for your tests. So some of them would be, for example, the square root of 4. So the square root of 4 is equal to 2. And I have other videos where I explain all of this, but another one would be 16. Right, so 16, the square root of 16 is equal to 4. So for right now, you just want to take my word for this because it's just going to make it a lot easier here. And the square root of 9 equals 3. So see this, we have a 2, a 4, and a 3. So these are all rational numbers. Now you might be saying to yourself, a 2 doesn't look like a rational number. Well, any number, it's always a fraction technically because you can write it over 1. So if you just see any random number, whether it's 4, whenever you see a 4 by itself, all right, you can always think of it as 4 divided by 1, even though we don't usually write it that way. So what's an example of a number that would not be a rational number? So let's think about the square root of 2. So the difference here, so I'm pulling a calculator up here because I don't know the square root of 2 off the top of my head. So the square root of 2 is 1.41 repeating, right? So let's just say the square root of 2 is about 1.41, right? So you see the difference here because 1.41, all right, that's not a rational number because this isn't a nice whole number, all right? This is a decimal, okay? So that's not a rational number. So that's kind of the foundation here. So basically, so let me clear this stuff out. So if you want to add these square roots to your notes, you can. But just know that I'll put a link down below. I've got a whole video where I break down the common square root. So don't worry about that. So right now we need to basically, let's do some math here. All right, so let's look at A. So right off the bat, we've got 2 fractions here. So whenever you've got to solve a question with fractions here, you can just multiply right across. So 5 times 3 is 15, and 2 times 11 is 22. So right off the bat, this is a fraction, so A is good. A represents a rational number. Now, what about B? Well, hopefully you can tell from that list, right? So I'm going to write this out here. From that list, remember that the square root of 4, remember I told you that that was 2. All right, so 1 over 2 is a fraction because the square root of 4 equals 2. So B is also going to be a rational number. So in C, hopefully you can see the problem here already, right? Because we've got, here's the problem. So we've got 2. And we've got square root of 2. Now remember, square root of 2 was about 1, what was it, 1.41, something like that. Yeah, 1.41 times the square root of 9, which is 3. So if we do the math here, if we do 2 times 1.41 times 3, okay, we're going to get some long number with a decimal most likely. So I'm doing that in my calculator. We've got 2 times 1.41 times 3. That gives us, it's not really that crazy of a decimal, but we've got 8.46. So it's got this 8.46, so this is not a fraction, all right? That's not a rational number, all right? And so, but without even having to do that math, if you just recognize that the square root of 2, it's not one of those nice common square roots right off that list that I showed you already. So C is out. All right, so what about D? So again, D, we can just tell here, we've got 2 times the square root of 9. So this we would rewrite to 4 times the square root of 18. Now 18 doesn't have one of those common square roots. Now you can take the square root of 18, but let me show you, it's going to give you a strange number. It's not going to give you like a nice whole number. So the square root of 18, that's 4.24, and see all these numbers here? All right, and that's in just to show you in contrast here. Like look at the square root of 16. That's just a nice simple whole number, that's 4. So 18 does not have a common square root, so therefore this is not going to give us a rational number. So D is also out here. So what about E? So right off the bat, we know that this is going to be a rational number. Why? Well, because remember, I showed you that the square root of 4, I already showed you that that's equal to 2. And I already showed you that the square root of 16 is equal to 4. So this really becomes 2 times 4, which equals 8. And so that is a rational number because remember, any number is always written divided by 1, even though we don't, well, it's always thought of as divided by 1. We don't usually write it that way, but that's how it is. So E is also correct. So remember, we're asked to find which 3 expressions represent a rational number, and so we found those 3 expressions right here. So we don't even have to check F, but just to point this out here, square root of 3 is not one of those common square roots, so that's why we would know without even doing the math here that we're not going to get a rational number.